All right, the last section for chapter 8 is pretty much going to rely on your ability to add rational expressions or fractions or whatever it was. And I say that because if you don't know how to create a common denominator, then you are definitely going to have major issues setting up the problem. The good news is once you set up the problem, the only denominator, or the denominator itself, is mostly insignificant. And what I mean by that is we'll find out that the denominator doesn't even take place in our solving portion of it because we're going to be solving these things instead of adding them. But it does show us what values can't be used, which will help us in case it's a no solution type of answer. But before you get into all the words and all that stuff, let's just take a look at the quick logical situation that we're looking at. So really what we're looking at here is x over 5 plus 1/2 equals 3/4. And so what we would do here is we need to kind of say what value is the common denominator for 5, 2, and 4. So 5 is not the number, and again, whenever I count for that, I usually count by the highest number. 2 and 4 cannot turn into a 5. What about 10? Well, 2 can turn into 10, but 4 cannot. 15, nope. 20, 2 can be a 20, 4 can be a 20. So what we would do is turn all these into a denominator of 20. That's going to multiply by 4, making that 4x. This is going to multiply by 10, making that 10. And this is going to multiply by 5, making that 15. In the end, here is my question. If it's 4x over 20 plus 10 over 20 equals 15 over 20, that actually simplifies if you add those up to be 4x plus 10 over 20 equals 15 over 20. Does the bottom really matter in the end? Because again, if 20 is here and 20 is there, all that matters really is that 4x plus 10 equals 15, which means in the end I just have to use solving for a basic equation. The question is, just kind of figuring out what makes that equation what it's supposed to be. And I believe that I should be able to write this, actually type this into my calculator to see, because I like this calculator for that reason. X is 5/4, so fraction 5 over 4, just to see if I got it right, plus 1/2 equals 3/4. There you go. So again, the process is it's generally straightforward. Find a common denominator, rewrite everything with the common denominator, and then for the most part you can ignore the denominator as you pretty much focus on the top. Because again, the top portion is going to give you your answer, but the denominator, if the denominator is not the same, then you of course don't have everything in a common language. So that represents the general idea of what we'll be doing. Of course, again, the values would be worthy of a honors student skill set, but the concept does not change. There are questions like this though where you need to be careful and not work so hard, because if you remember, you actually learned about proportions. You can solve that by finding a common denominator, but a fraction equals fraction is a proportion where you cross multiply. 2 times 6x plus 7 equals 5 times 2x plus 7. If you remember doing that in Algebra 1, that becomes 12x plus 14 equals 10x plus 35. Moving that would make it 2x. Moving that would make it, what, 21? And x would be 21 over 2. Again, check that out for yourself just to make sure. But again, the key thing to remember is that you need to make sure you distribute that 2 to both, not just multiply the 2 by the 6. So 12x and 14, 10x and 35. I subtracted 10 to get 2. I subtracted 14 to get 21, and then finish that out. So the key idea on A was just to make sure you remember that proportional work still happens. And this, by the way, should equal 1. So on a question like this, the thing is 3 over r, 6 over 7r equals 1. All right, well, initially what we're looking at is the common denominator, which of course you need room for a 7, you need room for a r. So I need 1. Actually, let's just go ahead and go through it. 7r, that's missing a 7. So that would be 21. That's missing nothing. So plus 6. Equals, that has nothing but a 1 on the bottom, which means I have to multiply by 7r, so it would equal 7r over 7r. Again, all I'm doing here is finding a common denominator for everything there, which you need room for a 7, because 7 is your number. You need room for 1r because both of these have 1r, and I just wrote them all. Instead of putting that over 7r, this over 7r, I just put 7r on the bottom, and I combined everything. So again, 3 plus 7 made 21. 6 stayed the same. 1 turned into 7r. Again, I can ignore that now and just put 21 plus 6 equals 7r, which means that 27 equals 7r, which means that you would end up with 27 over 7 equals r. Could we test that? I don't know. Let's see how good this calculator is. And I'm not going to check all of them, but just to kind of see. 3 over 27 over 7 plus 6 over 7 times 27 over 7. I do kind of like this for its ability to be very complex. Equals 1. Look at that. So again, the concept, not so bad. Find a common denominator, kind of like you did when you were adding fractions. Get the common denominator, rewrite everything, then ignore the denominator, except for the fact that with this denominator, r cannot equal 0. So what I meant by that is if there's a variable on the bottom, r can't be 0. So if we would have got the answer of 0, then we'd say no solution because 0 can't be used. Just like we had the discontinuity point on our graph, you can't use it if it's illegal. Here we are looking at x over 1. So 1, 5x, and 5 looks to me like 5 and x is going to be our common denominator. Again, that needs a 5 and an x, which means that we would end up with 5x squared. Here's the other thing that you have to keep. I would definitely distribute my negatives just like I did before. So this is missing nothing, so I would put minus 6 because that's your left side, equals, this is missing an x, so it equals x over 5x. So again, 1 is missing both, so I multiplied by 5x, getting 5x squared. That's missing nothing, so bring down your minus 6. This is missing an x, so bring down whatever 1 times x is. Ignore this and then solve it. So 5x squared minus 6 equals x, which means move your x over. And now we're looking for numbers that multiply to be negative 30, add to be 1. Of course, those numbers are 5 and 6, positive 6, negative 5. Separate 5x squared minus 5x plus 6x minus 6 equals 0. Split x, no, 5x, I'm sorry, which would leave x minus 1 plus 6 times x minus 1 equals 0. So you end up with x minus 1, 5x plus 6 equals 0. Feel free to pause the video and go through all that if you need to verify it. But again, don't forget in the end, you are setting that equal to 0, which means one of your answers is 1. You're setting that equal to 0, which means, remember, you'd have to subtract 6 divided by 5, so negative 6 over 5. Again, feel free to stop the video for that, but I am working this as if you've actually been working on the processes that we've been doing, and that is simply solving by factoring. But the general idea here is make sure that neither one of these two values breaks your denominator, which is 5x, where x cannot equal 0. And as long as that's the case, then both of those work. But if, for example, this was x can't equal 1, then that would mean that was what we call extraneous, and it would just be the negative 6/5. But again, just keep that denominator in mind, which is why I write it off to the side so I can go back and revisit it easily and then go on about whatever else is going on. This factors to be x plus 4. X minus 4, which means your common denominator is x plus 4, x minus 4, which means this is fine because it has both. This is missing x plus 4, so of course this is what's on the bottom. But looking at this again, that's going to be 2x plus 8. Now again, it helps to remember to distribute this negative. That way your life stays a lot easier. This is missing x minus 4. That would be minus 3x and plus 12. Which means in the end, that's insignificant. 8 equals 2x plus 8 minus 3x plus 12. There we go. So 8 equals negative x plus 20, which means negative 12 equals negative x because I subtracted 20. and then 12 equals x. Again, check that answer with this to make sure it doesn't break it, and it does not, which means that 12 should be your answer. Again, the process is simple. It's very straightforward. You just have to make sure you remember how to set up your common denominator, and then remember about those negatives that I hope you saw. Again, the safest thing to do anytime you have a minus is to distribute that negative to the top and make your life easier so you don't mess up on the distributing of negatives. Again, factoring as if we've actually worked on this. Numbers that multiply be 24, subtract to be 2, I believe is 4 times 6, so x minus 4, x plus 6. Remember, I know that the bigger number has to be whatever the middle sign is. That's done. Multiplies be 20, subtracts to be 1. Again, if it's got to be positive, then it's x minus 4, x plus 5. Done. And multiplies be 30, adds to be 11, I believe is 6 and 5, both positive because we're adding. Meaning that my common denominator is x minus 4, x plus 6, and x plus 5. I believe that covers everything when I look. So here's your x minus 4, here's your x plus 6, x minus 4, x plus 5, x plus 5, x plus 6. So therefore we know that that's what ends up here. So you don't need to write this, and as you get better you won't even write this, but just for the sake of keeping your notes standard, we are pretty much simplifying both of these sides so we can ignore the bottom. So again, I'm writing the bottom so it's standard in your notes so you know what we're doing, but in the end, if you know that that's going to be eliminated anyway, there's really no need to write it, because all that matters is that this is missing x plus 5, which means it would be x plus 5. That this is missing x plus 6, so it would be plus 4x plus 24. And that this is missing x minus 4, so it would be 3x minus 12. And once again, we did the work that we need to do, and this is insignificant, which means we end up with what? I'll just write it again, standard way. But again, what you could do from there is just combine your terms, which I'm going to do now. So 5x plus 29 equals 3x minus 12. Subtracting 3 to get 2x. Subtracting 29 to get negative 41, I believe. And then dividing by 2 to get negative 41 over 2. Doing a real quick check to make sure everything makes sense. 1x plus 5, yes. 4x plus 24, yes. 3x minus 12, 5x, 29, 12. Yeah, that's all I got. If it doesn't work, send me your work, send me what you got. But like I said, the answers aren't going to be nice because these are really complex things here. Again, the key thing though to remember when you get your answers, remember that 4, negative 6, and negative 5 don't work. So since that's not the case, that means that this does work. This is a geometric topic, but it does fit into this. But again, in geometry, you'll find out something about similar figures, and what similar figures means is that you take a shape and you expand it using the same proportions to fit something else. The nice thing about proportional figures is that if you set it up, as long as you set up the sides that are in the same position into your fraction, you should be okay. So what I mean by that is, looking at this fraction, I would put 2x plus 4 over 16. But since 2x plus 4 is in the same location as 6, I want to make sure 6 is at the top of this fraction and 2x is at the bottom of that fraction. Because 16 and 2x are related, and 2x plus 4 and 6 are related. As long as you set it up like that, everything will be fine. When you get into your honors geometry, it'll twist things up and make things more complex. But just remember that the parts that are related should be in the same location. As long as you don't have 6 on the bottom and 2x on the top, you don't mix everything up. From there, we just follow what we've been trained to do, which of course they're giving us a somewhat difficult algebra problem, but again, not too tough. 2x times 2x plus 4 equals 16 times 6, because remember, this is a proportion, cross multiply. That ends up being 4x squared plus 8x equals, that'll be 60 plus 36, which is 96. So moving because the elephant's on the boat, 4x squared plus 8x minus 96 equals 0. Here's a nice thing, 4, 8, and 96 all divide by 4, which means that if I divide everything by 4, which is a legal step, I end up with x squared plus 2x minus 24 equals 0, because 0 divided by 4 is 4. Meaning I'm looking for numbers that multiply to be negative 24, add to be 2, which I believe is, what, negative 4, positive 6. Keeping in mind another math trick we've learned, which is since there's nothing attached to x, we can just put those numbers into parentheses. And solving this, again, if you set that equal to 0, x is 4. If you set that equal to 0, x is negative 6. In the end, you have to remember that even though there are two answers, one answer does not make sense, because if you plug a negative 6 in for this, that means that that side would be negative 12. So that means negative 6 is extraneous. Because it says find the length of the unknown sides, it means that one side is 2 times 4 plus 4, which would be what, 8 plus 4 or 12. And that would be 2 times 4, which is 8. But look at that. 6 to 12 is doubled, 8 to 16 is doubled. It makes sense in the end. It's just the work you have to do to get to it. So again, that is your geometry introduction to things, but that's not a hard problem. Again, as long as you remember, just put whatever the two sides you have over there are in a fraction, and then make sure that whatever this side relates to is on the top with that number, and whatever this side relates to is on the bottom with it. All right. Doing this for the sake of just making sure that you can see how you're going to use your high skill set of algebra to help you out. So 1 over a plus 1 over h equals 1 over c, and they want you to solve for a, which means, if you remember, get a alone. That means, in my opinion, we're probably going to have to set this up like we normally would, ahc being my denominator, which means this needs an h and a c, which means this needs an a and a c, which means this needs an a and a h. Again, ahc is my denominator. This is missing h and c, so I multiply there. This is missing a and c, so I multiply there. This is missing a and h, so I multiply there. Which means we end up with hc plus ac equals ah. Of course, all over this. I don't think I want to deal with that just yet, though, because we would actually be looking at this. And the movements I'm going to make, well, the move I'm going to make, actually I guess I will start here because this is the legitimate setup. I'm going to move this over there. So with that said, it's going to end up being AH minus AC all over AHC equals HC over AHC, which is what I would have ended up with moving that over there anyway. I'll try to keep the AHC, but I don't think that I don't think the bottom is going to be the factor. But again, just trying to follow the rules of algebra that I've worked on. From what I remember, we would then factor, because remember, if you want A by itself, you need to factor that out. Or do we need to, you know what, that'd probably work better if we did a proportion. But I'll see. It's interesting, because right here, I honestly think, oh no, I'm not going to do all that. I hope that's not what the question wants. Let's see. Anyway, I'm going to ignore this, because I'm hoping that life is kind, not being mean. So I'm just going to look at HC equals AH minus AC. I'm going to factor out my A. And then, of course, if you factor out your A, you want to get rid of H minus C. You divide by H minus C. This, I believe, was in chapter 1. I think that's your answer. If it's not your answer, it's because it's going to go into a very, very, very deep process. And what I mean by that is we'd have to come back up here, rewrite this as that, yes, which is what it is, and then cross multiply. And here's the problem. You would have AHC times HC plus AC equals AHC times AH. Which means you end up with H squared C squared plus A squared HC squared equals A squared H squared C. Let me make sure that's right. That's distributing. 1A, 2 H's, 2 C's. And I should put C first, but as long as I'm consistent with the order of A, H, and C, I'll be okay. This is going to be 2 A's, 1 H, 2 C's. This is going to be 2 A's, 2 H's, 1 C. And then I want to probably, what do I want to do there? Putting all my A's together, you end up with, well, moving this over, you end up with A squared HC squared minus A squared H squared C plus AH squared C squared equals 0. I just moved that over there. Again, just writing this first because it was an A squared, writing this second because it's an A squared, and this third because it's an A. So I hope you understand why, looking forward, I went ahead and went this route, because I'm hoping that this is not putting you through this high level of algebra, because in the end we would have to now do some sort of factoring. A times, because all these have an A in it, because again, if A is my letter, it would be AHC squared minus AH squared C plus H squared C squared equals 0. I don't think you're going to do that, because the algebra involved in this is not algebra 2. I'll check it out, I'll look at the problem, and we'll see what happens. But I went through all that because I knew that was the last question. I do believe, though, that in the end, all we want to focus on is the top, which means once you go through that, it'll go. But again, I will get you word on that when I talk to you in class. I didn't cover all the problems that you're going to see, but again, the concepts of those problems that I skipped are very similar. Just be sure to communicate your issues as soon as possible with me so I can help you, but be sure to send it with work. Outside of that, again, good luck, and this is the end of chapter 8. You have a whole week now to get caught up, but if I were you, I would start making sure to get your homework up to 90 so you can actually practice on the pre-test before you take your test next week. So other than that, good luck, and I'll talk to you later.